This was a sort of introduction or general information about the column store. Now technology, now we are going to look into the column store at BI4Dynamics, what we have done in our setup and implementation of column store. So here it is. Now the first setup is data warehouse stage and fact setup, where in the property of data warehouse we can select whether we want to use column store on all staging tables and all fact tables. So by selecting this, all the indexes will be created by column store, all other indexes will be dropped, and the compression will be working as promised. Dimensions are not listed here, but dimensions can be table-based. Dimensions can be used in column store if we want to do it. So we would just click use column store index on the property of dimension in the wizard, and that would effectively change the format of the storage. We decided because dimensions are usually smaller, and everyone is saying that we should have, let's say, 1 million rows in a table to put it into the column store, maybe sometimes 100,000 in order to benefit. Otherwise, we are just wasting time because it will take time to process data or to build a column index. So we should not just put it everywhere. Now there is another small area where we also use column store on a temporary table, because we notice that sometimes when we put some conditions into the fact dimension, fact relationship, the execution plan just doesn't make sense, and the query that should process 10, 20, 30 seconds or minute can run for hours, and the execution plan is not as the data we are. So when we put a temp table into the column store, then this is sorting the problem out, and the script is processed fast. So we do only when we are having an issue with a slow execution because of the wrong execution plan done by SQL 2016 and later. Interesting. Now let's look into the performance tests on 100 million rows. The transaction table has actually 110 million rows already. We are going to see how the incrementally is doing by adding 1 million rows each time. Before we go into the test, so what are our expectations? We should see at least 10 times performance, 10 times compression, but regardless that I have shown you 6, 7, 8 performance gains, which are incredible good. You know, in reality, you may not expect the same results always. I mean, the same results if your data are different, then you may not have the same results as someone else. So not all tables can be supported in the column store because of the field type, or not all tables you would like to put into the column store because your SQL query, your SQL function would not support the column store. And this is where we are using it in the SUM functionality, where we are working with cursors. These two things don't go along very well. Now, a part of the query can be well supported by column store, and another part of the query may not be well supported by column store, or you don't have the gains. And, you know, definitely this is where we live. Building column store index takes time. And again, building column store index takes time. And it takes more time, probably more time, approximately. Our test show takes more time to create column store index than row store index. So in a very small situation, you can build index and takes more time, you get the benefit out of that. So you should not implement column store on a smaller set of data. Now let's see the data compression. So when we are looking into our data warehouse, and we have a staging table, we have dimension and fact table, we have information about the row store, and 100 million rows will take 34 GB of disk space, and most of the data are in the data area, very little indexing here. Now the same data compressed will take us 6 times space less, and is going to take less than 6 GB. Now looking into the smaller tables with 100,000 rows, we get some performance gains, but less than with the big table. Now we look into the all stage table, the performance gain in this scenario is 6 times. Now looking into the fact table, the same information that is in the staging table, which is actually a copy of your dynamics data, and the same number of rows here, will take less space because the data warehouse itself already uses the integers to store the information about the dimensions, similarly like we did in the step 2 of our Excel transformation. So that's why the data size is smaller and keeping the same information for sure, because the dictionary are now our dimensions, and the compressing integer will give us better result than compressing other column types, and this is 8 times. Now GL document entry, we have 100,000 documents in 100 million rows with 100 million rows and 100 million distinct values. That's why the compression is not that big. And these are dimensions which we did not compress, because if you're working with the column store, then the index area should show 0, which means actually the whole table is an index. So total gain, 6x. Next part is loading and processing, and this is very important. So we will not just remember 7 times. I mean, yes, please do, because this is a significant result and it's really, really, really good. Regardless whether you are loading a stage, it will load almost 7, 8 times faster. Column store is faster than row or data warehouse. But also, if we look into what if there is little more or a little less data, or let's look into also how the full update compares to D. So let's look into these results here. Let's start on the bottom. So the data are sorted by the total time, and we have twice incremental and twice full processing, once column, once row store, once row store, and one column. And the slowest processing is full update, of course, but surprisingly with a column store. And this is because it takes a lot of time to drop indexes and to create indexes back. And this is the same also in the data warehouse. It takes quite a lot of time to build these indexes, because column store actually puts all the table, the whole table, into the index. So everything is indexed. While row store, you may have only a few columns that are indexed. So this is 6,500 seconds in order to process 100 million rows. Now, a row store is faster, and especially loading the stage, while in the data warehouse it is slower, and mostly because of dimension building, because here we implemented row number over partition, while a row store we did not do this. So this is the difference in the gain. We have 5,785 seconds. Now incremental is 2.5, 3 times faster. A row store is 2.5, 3 times faster, and the data are okay. Still a pane is distinct, you see, while it is not the case for column store. And incremental is updating indexes faster. That's the gain here, and also this is the gain here. And loading data full or a portion is quite a difference. So that's clear. Now, surprisingly and happily, the winner is incremental updating 1 million rows in column store mode, which is 20 times faster than full update and 7 times faster than row store, which is really good. You will update data warehouse in 5 minutes, having 1 million rows, or added to 100 million rows already in that. Now this is excluding analysis services update, because there we can have tabular or multidimensional. So the focus here is only data warehouse processing, also because we are going to browse the data with Power BI directly. If you look into the details, so it's just not one number here, let me show you these results here. So there are several tests of or runs of testing process, and this 3I means we have been updating or measuring incremental third time, which means clean incremental, all the indexes already there, and we have been testing it by how much time needs more data. And first is a dry test, which means we are updating data warehouse without adding any data. So the result is 234 seconds. Now by adding 100,000 rows, we don't get much more time in the processing. It's just about, this would be average is 250, so 20 seconds, which is less than 10%, right? If we add 1 million or 1.2 million, we are requiring, we need 20% more time than with updating 100, or when we are updating 2 million, a little more than 1 million. So it's not linear, but the more data we update, we need relatively less time to process this data. And this is the same in deleting, updating stage, which means that what everyone is saying, that column store is better for loading data, which means loading stage. This is where we have this data, here, this column here, and processing data. And that is true. In both cases, we have around 7x gain. Good. The last part of the test is Power BI reporting, where we are browsing a Power BI report. So the result is 8x. So let's see this in practice in our scenario with Power BI. So this is a Power BI report with 5 filters, 2 tables, 3 KPIs, and 3 charts, a simple one. And we have recording of performance analyzer to see how fast 100 million rows will do us. So first let's clean everything so that you are sure that we have 110 million rows in a direct query on a cluster column store index. And let's clean this and just fire this. So the query takes 2 seconds. If we go to the next level, invoice, it's 1.3. Let's just go for a customer. It's beyond 1 second. And we select the GL account. It's beyond 1 second, which is good. Let's select the asset. Okay, this is good. And going back, just clean it back, just to see the performance. Usually when you're looking into, you are changing filter, looking by date, 2018, 2009. So a lot of the data are already cached here, so that's why I have a very good performance. Acceptable performance by Microsoft standard is 5 seconds, so this is always below 5 seconds, but in most of the time that I was doing, I was using 5 seconds maximum. So let's say this is a 5 second with 100 million rows in a data warehouse, a direct query. And the data model is our fact. surrounded by 15 or 20 dimensions. I didn't select all dimensions here. Now the results for a row store, I wouldn't even open a row store because it would take us too much time. It would not even work with 100 million rows because it works with 1, 10, maybe also more. It will just not show all the data always. This is the only problem that the Power BI report is the same, because it's not meant to be for a row store. And on average, I was getting the results between 40, 50, 60, 70 seconds on this. So it's a way slower, and definitely you would not consider your analytical tool, Power BI, to work against data warehouse, but in a row store. But if you are running a Power BI against compressed data warehouse, which means it's using column store, then this is really true what Microsoft says, that there are less need for analysis services if you're using column store. And in on-premise, it may not be so, because analysis services are already a part of the SQL Server engine and you don't pay extra for that. But if you are in the cloud, then analysis services are expensive because they are working in tabular route, which is working in memory, and memory in the cloud is expensive. It starts with a few $100s a month just, for a start. So that's a very good technology that can replace, in many projects, it will replace the need for analysis services. Conclusions? 6, 7, 8 times faster processing. So without additional cost, if you're already BI4Dynamics customer